Assalamualaikum and good morning, madam. Today our group will present an article critique. Here is our group member. I'm Haziq. We have Sheikh Nakib, Konstantin, Nadia Sofia, and Hazim Daniel. Our article of choice is Internet of Things-based smart electricity monitoring and control system using usage data by Hassan et al., published in 2021. We choose this article because it explores the application of IoT in smart electricity monitoring. In this presentation, we will briefly discuss the article's overview, strengths, weaknesses, and our overall conclusion. Let's begin with the overview of the article.
Okay, so I'll be covering the overview of the study. So the main goal was to build a smart monitoring and control system, or SMACS, for household appliances. So this was designed to solve two major power issues with older power monitoring methods, which they have high error rates and their lack of remote access. Next. So to achieve this, the researchers actually built a physical prototype using Arduino Uno, a current sensor, relays, and a Wi-Fi module. So for remote access, the system sends real-time power consumption data to ThingSpeak Cloud, which users can easily monitor right from their phones using the Virtuino app. Next. So now, finally, let's look at the result. The proposed system was highly accurate. When tested on a hairdryer, it actually achieved a very low error rate of just 0.6%. So as you can see in the charts, this is a massive improvement over the older systems, which had a whopping 7.8% error rate. So this alone proves that this new design is both accessible and highly reliable.
Now, the strengths shown in the research article are as follows. The first one is the enhanced measurement accuracy. As shown before, the SMAX proves to be a lot better than the older PMAS system, showing a minimum current error of 0.6%. And it even drops even lower when a higher current is used, for example, 0.29% with up to 1,500 watts. The second strength will be the integrated safety and control mechanisms. Other than monitoring how much energy is being used inside the house, it can also act as a relay. Whenever the current gets too high, it can send a warning to the user's mobile phone and can even cut the current whenever it reaches past that threshold. Now, the third one will be the superior communication technology. It utilizes a Wi-Fi module and it avoids operability and interference issues compared to old transmitters. It can also this Wi-Fi module also allows significantly faster data rate and also covers a broader network range. Now, the last one would be the practical IoT integration and usability. It implements platforms such as ThingSpeak and ThingSpeak for cloud data storage and Virtuino mobile application, allowing the users to remotely monitor their energy usage in real time. It also relies on accessible hardware like the Arduino Uno and the current sensor to develop a technology that is both low cost and less complicated than industrial alternatives. Next.
Moving on to the critical weaknesses of the study. First, the methodology relies on unvalidated assumption. The authors fix a voltage at 200 VAC and assume a static 0.90 power factor instead of measuring them directly. In real world grids, voltage fluctuates, making their power calculation fundamentally inaccurate. Second, testing was far too brief, lasting only 5 minutes in the lab. This misses sense the thermal drift and dynamic startup currents. Additionally, evaluating accuracy against historical data from an older separate study introduced uncontrolled variables, invalidating the comparisons. Finally, the architecture presents serious privacy and safety risks. Household energy data is transmitted and encrypted over Wi-Fi, while high voltage AC switching relies on chip with 5V relays without optocouplers or snubber protections, creating real fire hazards. Thanks.
All right, to conclude, this study shows that affordable IoT technology can effectively monitor and control household electricity consumption in real time. By integrating sensors, a microcontroller, cloud storage, and a mobile application, the system provides accurate measurements and convenient remote access. It also has the potential to improve energy efficiency, reduce electricity wastage, and enhance household electrical safety. However, the study still has several limitations. The system was tested only for a short period under controlled laboratory conditions, while important values such as voltage and power factor were assumed rather than measured directly. There were also limited discussions on cybersecurity and circuit protection. Therefore, future research should focus on long-term real-world testing, stronger security measures, more accurate electrical measurements, and predictive energy management features. Overall, the system is a promising proof of concept, but further improvements are needed before it can be widely implemented. Thank you very much.
Thank you.